This is KK, and today we'll be starting trigonometry. Trigonometry basically consists of two Greek words, trigonon, which means triangle, and metria, which means measurement. So what is the basic task of trigonometry? The basic task of trigonometry is to solve a triangle, or we can say it gives us the solution of the triangle. So solving triangles originated in astronomy, and for a long time trigonometry was a branch of astronomy. It was only in 18th century when trigonometry got its modern form, and it was due to the great effort of Euler. Okay? So once we say that we have to solve a triangle, so what exactly we have to do? So we have to find the unknown quantities of a triangle from given values of other of its quantities. For example, we can see that suppose we have to find angles of a triangle from given sides. So we can say that if sides have been given, we have to find the angles of a triangle. Or suppose we have to find the sides of a triangle if area and two angles have been given. Okay, trigonometry is all about solving triangles. So if we are solving spherical triangles, that will be called as spherical trigonometry. Okay, spherical trigonometry. And if we are solving plane triangles, that is called as plane trigonometry. So we'll be dealing in plane trigonometry. Let me take a right angle triangle ABC. Okay, so suppose this is a right angle triangle ABC. This side is small a, this is small c, and this side is small b. So how we relate a, b and c? So we all know this Pythagoras theorem. So c is given by under root of a square plus b square. So this is an algebraic relation between a, b and c. But if any other triangle is there, for any arbitrary triangle, suppose we have to relate angles with sides. So for that purpose, we should be having some new function, or we should be having some new instrument to relate sides with angles. So these functions are called as trigonometrical functions. So here we'll introduce the concept of trigonometrical. So this is the concept of trigonometrical functions or trigonometric functions. So first let me clarify on a very basic level what is the meaning of a function. So suppose we are having some input. This is the input, and this is an instrument. Suppose f is the instrument, and if we'll put input here, we'll be getting the output as f of input, and this is the output. So what is the function here? We'll be having, instead of f, trigonometric functions. Okay, so basically function is an instrument. So function takes some input. Okay, so function is an instrument which takes some input to give some output. So in case of trigonometrical functions, what is the input? So in case of trigonometrical functions, the input is what? The input is angle basically. So angle is the input, and what is the output? Some particular value. Okay. So basically we are having 6 trigonometrical functions. So these functions are sine of that angle, let us take this as theta, cos theta, tan theta, and sine theta is given by 1 upon cosec theta. Cos theta is given by 1 by sec theta, and tan theta is given by 1 by cot theta. Okay. So now we will see what is the meaning of these functions in a right angle triangle, and later on we will see that these functions can be generalized to any triangle. So let me draw a right angle triangle. Suppose this is a right angle triangle A B C. This side is A, this is the hypotenuse C, and this is B. Now we are having 3 sides. One is AB, BC, and CA. Suppose we are taking angle A. For angle A, what is the perpendicular? This is sign for perpendicular. So perpendicular side is the opposite side to that corresponding angle. Suppose we are taking angle A, so perpendicular for this is the opposite side BC, and this side on which the angle lies is the base. So perpendicular for this is A or BC, and base for this is B or AC. Okay. Now again we can do this same thing for angle B. For angle B, the perpendicular is the side opposite to the angle. So for B, AC is the side which is perpendicular. So this is B and this is equal to AC, and the base will be equal to, for angle B, BC is the base. So this is BC and this is equal to A. Relate angles to the sides. So sine theta is given by perpendicular by hypotenuse. Cos theta is given by base by hypotenuse, and tan theta is given by perpendicular by base. So cosec theta will be given by hypotenuse by perpendicular. Secant theta or sec theta is given by hypotenuse by base, and cot theta is given by base by perpendicular. Okay. So here we are having a simple technique to remember this. Sine theta, cos theta, and tan theta. Okay, so how we can remember this? Very easily, we can remember like this. So this is Pandit Badri Prasad Hari Hari Bol. Okay, now again I'll tell you that sin theta is given by P by H, cos theta is B by H, and tan theta is P by P. So we can remember this very easily in Hindi. Pandit Badri Prasad, Pandit for perpendicular, Badri for base, and again Prasad for P, Hari for hypotenuse, and Bol for base. So sin theta is given by P by H, cos theta is given by B by H, and tan theta is given by P by B. Okay, so if we have to find opposite of this, cosec theta, suppose we have to find cosec theta or sec theta or cot theta. So cosec theta is given by H by P, sec theta is given by H by B, and cot theta is given by B by P. Okay, so you can remember this like this also: Pandit Badri Prasad Hari Hari Bol, for sine, cos, and tan. This is for sine, this is for cos, and this is for tan. Okay, now we know the formula for sine, cos, tan theta. We can derive very important identities or formulas. So let me start with tan theta. Tan theta is given by P by B. So this can be written as P by H divided by B by H, and P by H is sine theta and B by H is cos theta. So we are having very important identity: sine theta divided by cos theta is equal to tan theta. Okay, now second is sine square theta plus cos square theta is equal to 1, or you can write this as sine square theta is equal to 1 minus cos square theta, and this is given by 1 minus cos theta into 1 plus cos theta. I have applied this formula: a minus b into a plus b. This is given by a square minus b square. Okay, you can write this as cos square theta is equal to 1 minus sine square theta. So you can write again this as 1 minus sine theta into 1 plus sine theta. So how will prove this? This result is very important. So this can be proved very easily. How? We can write sine square theta as p square by h square, and cos square theta as b square by h square. Take LCM of h square and h square. This is h square itself. So in the numerator we will be getting p square plus p square, and from Pythagoras theorem, that is h square. So this is equal to 1. Okay, since h is not equal to 0, hypotenuse can't be equal to 0, we can divide by h square. Okay, so this is equal to 1. So this is the proof for sine square theta plus cos square theta is equal to 1. Now, third one is secant square theta minus tan square theta is equal to 1. Or you can write this as 1 plus tan square theta is equal to secant square theta. Okay? Another way of writing this as secant square theta minus 1 is equal to tan square theta. Or you can write this as secant theta plus tan theta into secant theta minus tan theta is equal to 1, because a square minus b square is nothing but a plus b into a minus b. Okay? So how I'll prove this result is secant square theta minus tan square theta is equal to 1. So what is secant square theta? H square by b square. And what is tan square theta? P square by b square. So this will be given by h square minus p square. And from Pythagoras theorem, h square minus p square is nothing but b square. So this is equal to 1. Okay? Now next formula is cot or cosec square theta minus cot square theta is equal to 1. You can write this as 1 plus cot square theta is equal to cosec square theta. You can write this as cosec square theta minus 1 is equal to cot square theta. You can also write this as cosec theta minus cot theta into cosec theta plus cot theta is equal to 1. So you have to write the form, you have to remember the formula in all the forms. Now, what is the proof for this? Just like the previous case, cosec theta is h by p, so cosec square will be h square by p square, and cot square will be what? B square by p square. So this is h square minus b square by p square, and this is equal to p square by p square. From Pythagoras theorem, h square minus b square is equal to p square. So this is equal to 1. Okay, so these are having fundamental trigonometrical identities. Okay, now we'll proceed further. I can summarize whatever we have done till now as I can use this space. Pandit, Badri, Prasad, Hari, Hari, Bol. So this is for sine theta, p by h, cos theta is b by h, tan theta is p by b. Okay. Now sine square theta, I'll do it fast. Plus cos square theta is equal to 1. Secant square theta minus tan square theta is equal to 1. And cosec square theta minus cot square theta is equal to 1. Okay. Now we'll try to figure out the values of trigonometrical functions for some standard angles. Okay. So these angles are 0 degree, 30 degree, 45 degree, 60 degrees and 90 degrees. Okay. First we'll see sine function, then cosine function, then tangent function. So what you have to do, write first 0, 1, 2, 3 and 4, and write this in reverse order. For cosine, this is 4, 3, 2, 1 and 0. Okay. Now you know tan theta is equal to sin theta by cos theta. So divide these two quantities to get 0. This is 1 by 3. This is 2 by 2. This is 1. 3 by 1 is 3. And 4 by 0 is, for this time being, let this be infinity. Okay. Now what you have to do, divide this by 4, 1 by 4, 2 by 4, this is 3 by 4, and this is 4 by 4. Do same thing for cos also. Okay. Now you don't need to divide this in tan, because tan theta is equal to sin theta by cos theta. Now take square root of all the quantities. Okay. So this is root 3 by 4. This is under root of 4 by 4, that is equal to 1. This will be under root of 4 by 4 and so on. Okay. So do it for all the quantities, whether this is sine, cos or tan. Okay. So this way you can remember the values of certain trigonometrical functions for some standard angles. Okay. Now here you can see the values: sine 0 degree is 0 for 30, 1 by 2, 45, 1 by root 2, for 60, root 3 by 2, and for 90 this is 1. For cosine, it's 1 root 3 by 2, 1 by root 2, 1 by 2 and 0. Similarly for tan, you can see the values. For tan 90, this is not defined. You can find cot from tan, sec from cos, and cosec from sine theta. Okay. Here you can see the previous values. You can see this table. Okay. Now we'll proceed further for certain identities. Okay. There are certain identities which are, first I'll take, now let me draw a right angle triangle A B C. BC is A, AB is C, and AC is small b. This angle is supposed theta, so this angle will be 90 minus theta. Okay. Now suppose we have to find sine of theta. What is this equal to? BC by AB. So that is small a by small c. Okay. And what is cos of 90 minus theta? This is given by what? Base by hypotenuse. So this is a by c. Okay. Now what is the relation that you are getting? You are getting relation as sine theta is equal to cosine 90 minus theta. Okay. So sine theta is equal to cosine 90 minus theta. Okay. We can write similar relation: cos 90 minus theta is equal to sine theta. Okay. Now we can write tan 90 minus theta is equal to cot theta. Cot 90 minus theta is equal to tan theta. Okay. Similarly, we can write sec 90 minus theta is equal to cosec theta, and cosec 90 minus theta is equal to sec theta. Okay. Now we can verify these results from the table also. You can see the value of sine for 0 degree is for cos 90 degree, sine 30 is cos 60, and sine of 45 is cos 45, sine 60 is cos 30, sine 90 is cos 0. Okay.